Hi everyone, my name is Mariam. I'm a software engineer and I'm part of the JEDI core team. And today I'm gonna talk to you about the testing framework in JEDI. Okay, so first I'm gonna start by showing you this figure and then also talk about the why testing is so important in the development of JEDI or any scientific software for that matter. So in the development of JEDI, we use a variation of agile methodology. So that means that we develop the code in an iterative process. So we break the code into smaller pieces. So we set smaller goal or targets, and then we work on these pieces or goals in one iteration. So we develop that piece of code, and then we run our tests that we have in JEDI. And then after all the tests pass, and after reviewing that part of the code, we merge that into the main repository. So when we do that, it helps us test the code and be sure that it's working correctly before merging that into the system. Because we have worked on only a small piece of code, it's easier to fix any issues that we are seeing compared to if you just add a really lots and lots of lines of code into the repository. And then at every time, we are sure that the code is working correctly. So usually what I mean by small pieces that a new feature that you're trying to add to the code should take you maybe a couple of days to a week to work on. Anything more than that, we really suggest and recommend to break it into smaller pieces. So it's going to be easier for us to review that. And then, so if we want to look at different types of tests in JEDI, we can kind of roughly classify them into unit tests and application tests. So by unit tests, what I mean is that these tests are very small tests that run really fast, and they test each component of the code. So something like, is the input correct? Or when I run this piece of code, the answer that I get, is that close to a known answer or not? Application test is mostly refers to running a bigger piece of code or a whole system, and then again, compare it to known answers. So in JEDI, we use CTest, which is CMake test driver program to run our tests. So you basically run the tests after you build and compiled the code in the practical previous practicals. So here I'm just reviewing the commands that you can use to run these C tests, and then you can refer to this slide later to remember these commands. So when you want to run the C-test, you can simply type C-test, and then with that, all the tests that you have in that build directory will run. So after the test is done, it will give you a summary, like here, as you see here in the screen, of which test passed, which one failed, how long it took to run the tests, and so far. So if you want to run one specific test, you can use -r flag after C-test and then have your test name here. And then you can, if you want to output details and have a more verbose output of your test, you can add -v or -vv option to your C-test. If you have a bunch of tests failed, like this example, and you want to run them again, you can use this --v run failed to run the tests again. If you want to have another way to get more detailed output for debugging purposes from the tests is that you set oops debug and oops trace to 1 when you're configuring and building the tests, the bundles, sorry. So I also put a link here for you, so you can refer to this, read the document. It has lots of details about how we run C tests in JEDI. And also something that I want to point out is that we spend a lot of time developing these tests and making sure that they are working correctly. So if you build the bundle and if you see some of the tests are failing, it means that something is not correct. So make sure that before making any changes to the code, make sure that all the tests are passing and then start working on the code. Otherwise, it will get difficult to debug your code later on. Okay, so now I'm going to talk about the structure of JEDI testing framework. Basically, if we want to, we can say that there are mainly 4 sets of files that are important when it comes to testing in JEDI. So we have the header files, we have the source files related to testing, we have the YAML file that's related to testing, and we also have this test cmakelist.txt, the cmakelist that's located in the test directory. So in this slide and the following slides, I'll try to kind of summarize how these files are located in JEDI repositories, specifically in OOPS. So here I have the example, like I'm showing the kind of the file or directory structure in OOPS repository. So we have this OOPS. When you go under source, you can see we have this OOPS, and then we have all these classes. And then Dan in the previous lecture briefly talked about all the kind of classes and header files that we have in each of these directories. So mirror to that, we have this test directory that kind of follows the same structure as OOPS directory. And then when we look into the interface, for example, directory, we see all these header files that are basically that are defined in OOPS, but then implemented in different models. So you saw some examples in FP3 JEDI in the last lecture. So you can also see the implementation of these headers in, for example, the TOEI models that we have in OOPS or any other model that we have. So we have these kind of headers here under OOPS interface. And then if you look at test interface, you will see like the same classes with the same name are located there. So these header files are designed to basically test the corresponding classes that we have under the interface directory. For example, you can see GeoVals here, and you have GeoVals here. So basically, this is responsible for testing the GeoVals on their interface. Okay, so we have these header files. Now we want to see where the source directory, source files or .cc files are located. So again, I'm showing test interface directory and all the header files that we have here in OOPS. And then if we look at the QG toy model repository, you can see that, again, we have QG test, and then there's this executable directory there. This holds all the source files or all the .cc files that are related to these header files. For example, we have test geometry. So this refers to this basically uses this geometry class that we have in order to test the geometry class. Another example, like similar to that, we have this test mains under FP3 JEDI. So usually the .cc files are either located on their executable directory or on their mains directory. Depends on the repository. But if you get a chance and go explore different repositories, you can see a similar pattern in all of them. So again, like we have test geometry.cc here, which will kind of use this geometry.h to test geometry class in OOPS. So now let's look into this header files and this .cc files. Here I'm just going to point out some of the important components in the header files. So I have the example here. So we have test interface, and we are looking at getValue.h. So when you look into this header file, one of the important kind of sections or functions that you can see in this header file is text fixture. So if you look at different header files, you can see that the text fixture test fixture is also used in other header files as well. So the responsibility of this test fixture is that they will basically create objects based on relative sections of the configure YAML file. For example, here let's look at getValue.h. So we have getValue fixture. So the first part is going to be the name of that header file and then the fixture. And then here we're going to read from the YAML file all the variables that are going to be important for this test. For example, in this section, we are using geometry, and then we allocate this resolution object that will point to this geometry value. And then so this geometry value corresponds to this geometry section in the YAML file. Similar to that, locations, we have locations here. And then when you look at the YAML file, you see that locations refers to this section of the YAML file, basically. So now that you have these objects created and then pointing to the values that you want to use in your header files, you can simply use these objects instead of kind of running this line again and referring to YAML and read the YAML again. So yeah, this is test fixture. And then another kind of function that you will see in the header files, in different header files, is the test constructor. So here it's called test get value, which is the name of this header file constructor. So the purpose of this class is to make sure you construct and destruct the objects correctly. For example, in this example, you can see that we are creating this get value object from resolution and locations that we read in test fixture. And then after that, we just make sure that it exists using expect command. And then we destruct that get value object, and then we just check to make sure that it's destructed correctly. Okay, so another important section in the header files is towards the end of the file. So you have this void registered tests. So all the kind of sections or classes or functions that you have in this header files, you need to register those with CMake, basically. So for that, you will use like a structure or commands similar to this example that I'm showing here. And then, so this register test will basically register all of these subtests to the CMake. And then after that, when you run ctest, it will run each of these subtests for you there. Okay, so here, so these are just some examples of how you can use expect. I just put them here for your reference in the future. So as the name kind of implies, so the statement that's in the expect must be true for the test to pass. For example, in this example, this statement must be true. And then so you can like compare two values in expect. You can also use a command called is close to compare two values within an acceptable tolerance range. It also accepts greater than, less than signs. Yep. Okay. So now let's look into what .cc or source files and what we can see there. So these .cc files are usually are always pretty short. So for example, here I'm showing an example of the get values test. So in FE3 JEDI, so it's test get value.cc. And then so the structure is like, if you look at different .cc, it's the same basically. You just change the include statement here to include the header files that you want to test, and also you will need to modify this. And then you run the test using this execute method, and this execute method, if you want to go and look into details, you can find it's defined under test.h in this location. Similar to that, if you want to look at another model, for example, QG, you can see that it follows the same structure there, except that you're testing QG model instead of FV3 JEDI. And then again, you have this run execute tests that will kind of use this test.h to run the tests for you. So also here, I just put kind of part of a section of this test.h for you if you want to refer to that later, and also a link to that if you'd like to look at the whole code there. Okay, so now that we've looked at .h file and .cc files, let's look at the CMake list.txt. So here I'm just showing you the directory structure that we have for FV3 JEDI tests. So we have this CMake list.txt there. So in this CMake list, you will define, first of all, you would define all the YAML files, all the test data and everything you're gonna use for testing. So kind of register that with CMake again. And then this EC build add test function will actually add the test for you. So whatever name that you use here for your test, when you run ctest, you will, the names that you see for the test there is coming from this this line in test CMake lists. And then how you want to run the test, what's the executable that you want to use, if there's any YAML file that's that you need to provide as an input for your tests, and so far. So I suggest that you go into different repositories and take a look in at the test CMake list.txt there. So another directory we talked about, that it's mains that will include all the source files. Then you have test input. So in test input, you will the test input includes all the YAML files that you need to in order to run the tests. So it will have the name of the test here, following by .yaml at the end. So these YAML files, you actually worked with some of them in previous kind of practicals. So it's gonna include all the information that the test needs in order to run. And then after you run the tests, you will create some outputs, and you want to make sure that these outputs are correct. So in test output, you basically put all the reference files. So these are known answers that I talked about. So after you run the test, you get an output, and then you compare it with this reference files that are located in test output. So this test input and test output directories, you will find it in all the repositories, JEDI repositories under test directory. So you can also go ahead and take a look at those when you get a chance. So here I'm just, again, rephrasing what I showed in the previous slides. In the last slide, we looked at FV3 JEDI. Now let's look at L95, which is a toy model in OOPS. So we have executables that will hold all the source files. We have test input that holds YAML files, and then test outputs, which holds the reference files here. Okay, so how do we compare the results with the reference files that I talked about? So this is like a relatively new feature that we've added that compares the test outputs with the reference file within C++. Before that, we were using a Python script, but now it's kind of incorporated into at C++ level. So if you want to kind of activate the comparing process that compares the test log with the reference file, you will simply add this test section to your YAML file. So you can refer to this example here on the on oops repository, it will have kind of, you can take a look at that and see like to make sure that the indentation is how the indentation is set in the YAML file. So you have this test section, and then under that you have the reference file name. So this is the reference file that you want to compare your output to. And then you have these optional kind of keys that you can use if you want to. So one is that, so let me just first show you how this reference files look like. So this is an example of a section of this for the ops bias test reference file. So you can see that there are strings and numbers there. So you can see what's the JO or JB has been after you run this test, or number of observation, or the errors, or like different kind of values you will, or statistics you will have there. So you want to compare these numbers with your output. So you can basically set some tolerances there to accept some like small range of errors. So based on that, then your test will pass. Sometimes you will need to, like, especially for float relative tolerances, you need to set a very small number there. Otherwise, the test will fail. The default here would be 0. So you may want to use, like, if it's 0, we don't need to set these two options. If you want to use any other value, you can like use this key to set this tolerance values. And also this log output file name will, if you want to actually save the test output that you have for debugging purposes, or like if you want to update the reference file, you can add this log output file name there and then give it a name. With that, it will save the test output for you. So again, I put a link to read the docs document that we have, so you can refer to that for more details. If you want to add a new test to JEDI, there are basically 7 steps that you need to take, but most of them, like from number 1 to 5, is already in place for you. I'm saying probably because depending on what you're trying to add to the code, it's very likely that most of the infrastructure is already in place for you. So usually what you need to do is take step 6, which is create the YAML file, and then step 7, which is register your files with CMake, and then add your ctest using ECBuild add test. So if you like want to kind of understand the whole, I know that it may be a bit complicated. So I really recommend, like, if you want to understand this more deeply, refer to all the examples that we have in the OOPS or UFO repositories, looking at the header files, looking at the executables, and then the YAML files, look at test CMake list.txt. This will all help you understand the process even better. Also, another point is that when you add a new test, make sure that you also test the test. What I mean by that is that, so make sure like your test is failing when it's supposed to fail. So you can like kind of work with the YAML file to see if, for example, if you set the tolerance to 0, is that going to fail? Or like things like that, basically. So make sure that you test your test and make sure that your test fails when it's supposed to. Okay, so now I'm gonna kind of switch gear and then talk about like how we are running these tests on GitHub, how is the automated testing framework implemented in GitHub, and so far. So I showed you this figure on the first plot, and then here I'm kind of showing the process of kind of adding a new piece of code to the repository. So when you try to add a new feature to JEDI, one of the JEDI repositories, you issue a pull request, and then the reviewers will review that pull request for you. If everything looks good, you can merge the code will be merged into the repository. If not, it will go back to you, the developer, to improve the code based on the comments. So we have added this automated testing framework to this process, meaning that the reviewers, when you issue a pull request, a bunch of kind of containers will start running, and then in these containers, the code will be built, and then all the tests will run. And then the result of these tests will be printed on the GitHub page. So this is similar to what you did on the first practical, where you build the code and ran the tests. And then if all the tests pass with the new feature that you've added, then the reviewers will review the code, make sure that it's scientifically correct, everything makes sense, and then after that, it will get merged. If there's a test failure, the code developer should take care of that and make sure that all the tests are passing and everything is working correctly. So we use AWS code build to run our tests, and also we store our containers on AWS ECR for automated testing purposes. So Mark talked about these containers in his lecture. So we basically have 3 main containers based on GNU, CLang, and Intel compilers, and we run these 3 containers. We run the tests in these 3 containers in parallel when you issue a PR. So on our GitHub page, after you issue the PR, these containers will start, the tests will run, and then the result of the test will be displayed on the PR page in a format like this. So if all the tests pass, you will get green checks, which is good. If not, you will get red cross, meaning that something went wrong and you need to debug the code or solve the issue that's with the testing. So this is just an example, again, of some screenshots of how these automated testing interface look like. Another tool that we have incorporated in our GitHub page is code coverage. So this basically shows how much of the code we are testing. So it's very, very important that when you add a new feature to the code, you also write a test which tests that new feature. So code coverage basically helps us keep track of that. So if you don't add a test when you're adding a new feature, that the code coverage basically will go down with your PR, and then we will all be notified. It will be on the PR page. We will kind of tell you, hey, can you please add a test to this feature that you're adding, because it's reducing the test coverage, and we need to make sure that the new feature is tested properly in the repository. So again, these are some examples of the test coverage that we have currently for our repositories. So another feature that we've recently added is that because we are using CTest, we can upload the results and outputs to a server or a user interface called C-. And then C- will kind of summarize all the builds that we've done. And also, if there is a test failure, it has a nice interface that you can click on that, see the details of the test failure, and it will help with debugging the code. So with that, we have, like, in the checks section of the PR, other than the code build output that you see, we use webhooks to basically create the 3 links corresponding to different compilers that we have. And when you click on this will take you to the C- page. So you can look at the details of each of the tests there. Okay, so this is my last slide. Just to summarize, make sure you add a test when you're adding a new feature. Also, please run the tests before you issue a PR. make sure all the tests pass for you before you issue the PR, because running all these code build projects, it costs some money. So it's always a good idea that you check the new feature first. You test that before issuing a PR for others to review it. So I highly recommend, if you want to understand how the system works, go and look into the test. These are great examples of how the code is used in JEDI. And again, I put some references here for you if you want to read more about testing in JEDI.